Solve problems on vibration in the system due to base or foundation excitation or motion transmissibility. Given question: a motor car moving with a speed of 100 km per hour has a mass of 1500 kg. It passes over a rough road which has a sinusoidal surface with amplitude of 75 mm and a wavelength of 5 meter. The suspension system has a spring constant of 500 Newton per millimeter and the damping ratio 0.5. Determine the displacement amplitude of the car. This is the question for vibration in the system due to base or foundation excitation or motion transmissibility. Let us understand given data with the help of diagram. Velocity of the motor car is given 100 km per hour, but the standard unit is meter per second. So we will simplify this as 100 multiplied by 1000 divided by 3600, which is equal to 27.77 meter per second. And we will show this velocity of this motor car is here. Now the mass of vehicle is also given 1500 kilograms. So here is the mass m. Then the base is given in the sinusoidal form. That is, we have to draw here the sine curve. Now the amplitude of base is given. We will say here this y is equal to 0.075 meter. So this amplitude we will mention here as a y. Now the wavelength is also given. So wavelength is 5 meter. So for this sinusoidal base we have to show the wavelength, that is the distance in between these two upper points, that is lambda, and which is equal to 5 meter. Now the spring stiffness K. So here is the spring in between this motor car and this base, which is having stiffness K and is equal to 500 Newton per millimeter, but standard unit is Newton per meter. So we will simplify this as a 500 into 10 raised to 3 Newton per meter. Then the damping factor zeta is also given. So zeta is equal to 0.5. And now we have to find out the displacement amplitude, that is capital X. We have formula for motion transmissibility. X by y is equal to magnification factor ohm under root of 1 plus 2 zeta r bracket square. Now we have to first find out this r, that is the frequency ratio, and which is equal to omega by omega n. So first we will calculate omega n, which is equal to under root of k by m. So value of k and value of m is mentioned in the question. So omega n is equal to 18.25 radians per second. Now we will find out the value of omega. So how to find out this omega? So we know that 2 pi by omega is nothing but time period t, and this t is equal to lambda by v. So lambda is the wavelength which is mentioned in the question, and v, that is the velocity, is also mentioned in the question. So we will write here 2 pi by omega is equal to phi divided by 27.77. So omega is equal to 34.90 radians per second. So r is equal to omega by omega n, which is equal to 1.9119. So this is the value of r. Now from this value we can find out the magnification factor. So we have formula: magnification factor is equal to 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square. Now value of zeta is known as well as value of r is also known. So when we calculate, we will get the answer 0.3056. And now we will calculate x. So x is equal to y. So y is 0.075 multiplied by magnification factor, that is 0.3056, multiplied by under root of 1 plus 2 into zeta, that is 0.5, into r, that is 1.91 bracket square. So when we solve this, we will get the answer, that is the displacement amplitude x is equal to 0.0494 meter.
Given question, a vehicle has a mass of 490 kg and the total spring constant of suspension system is 58,800 Newton per meter. The profile of road may be approximated to a sine wave of amplitude 40 mm and the wavelength 4 meter. Determine first critical speed of vehicle. Second, the amplitude of steady-state vibration of mass when vehicle is driven at critical speed and damping factor is equal to 0.5.
Let us understand the given data with the help of diagram. Mass of the vehicle 490 kg, spring stiffness 58,800 Newton per meter. Now the base is given in sinusoidal form and its amplitude y is equal to 40 millimeters. So standard unit is meter, so which is equal to 0.04 meter. And the wavelength lambda, so if we observe the base in the sinusoidal form, then this is the amplitude y and this is the wavelength lambda. So lambda is equal to 4 meter. Now as per the given data, we will move to the first question. We have to find out the critical speed of vehicle, that is Vc. Now what is the condition for the critical speed? So at the critical speed, system vibrates at its natural frequency. So we can say that at critical speed omega is equal to omega n. So we have to consider the frequency as a natural frequency, that is omega n. So we will first calculate the natural frequency omega n. We have formula omega n is equal to under root of k by m. So value of k is given, m is also given. So when we calculate, we will get 10.95 radians per second. So this is the natural frequency. Now we know that the time period t is equal to 2 pi by omega and which is equal to lambda by v. So this is the formula, but here the condition is given the critical speed of vehicle. So instead of omega, we have to consider omega n, and instead of speed v, we have to consider Vc. When omega is equal to omega n, then v is equal to Vc. So we will write the formula 2 pi by omega n is equal to lambda by Vc. So we will put the value of omega n, that is 10.95. We will also put the value of lambda, that is 4 meter. So only one unknown term, that is Vc, and when we calculate Vc, we will get 6.97 meter per second. Now we will move to the second question. We have to find out amplitude of steady state vibration of mass when vehicle is driven at critical speed and zeta, that is damping factor, is equal to 0.5. So we have to consider this velocity as a critical speed, that is Vc, and we know that for the critical speed condition is omega is equal to omega n and r is equal to 1. So we have to find out amplitude of mass. So amplitude of mass is x, and we have the formula for motion transmissibility. X by y is equal to magnification factor under root of 1 plus 2 zeta r bracket square. So value of y is known, that is mentioned in the question. So we will put the value of r is equal to 1 because this is the condition for the critical speed. So when r is equal to 1, then what is the answer for magnification factor? So magnification factor ohm is equal to 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square. So when we put r is equal to 1, then it is equal to 1 divided by under root of 2 zeta bracket square. So this square root and square is getting cancelled and it is equal to 1 by 2 zeta. That is zeta is 0.5. So this is the condition given. So it is equal to 1. Now we will calculate the value of x. So x is equal to y multiplied by magnification factor. So y is given 0.04 multiplied by 1 multiplied by under root of 1 plus 2 into 0.5 into 1 bracket square. So answer is 0.0565 meter.